Mr. Kotresh, Durgad, Assistant Professor of Chemistry, Vijayanagara College, Hosapete. Now we will go ahead with the discussion of coordination compounds. Now, first we can go ahead with how this coordination chemistry existed in the field of chemistry. During the preparation of addition compounds, by mixing two or more simple inorganic salts, we can obtain a crystalline compounds. These fall into two categories. One are called as double salts, second one is complex salts. What is the difference between these double salts and complex salts? Now, these double salts and coordination compounds, though they are considered as addition compounds formed by the combination of two or more simple inorganic salts, they are differing in the following aspects. Double salts exist only in solid state and do not lose their identity in solution with respect to the components of the reactants. Coordination compounds lose their identity in some of the components of the reactants when they dissolve in solution. This is the major difference between the double salts and coordination compounds. Examples for the double salts are more salt, cornlite, and potassium. Thus, the examples for the coordination compounds are the ferrous ammonium sulfate. Then the coordination compounds are hexamine cobalt complex. That's the tetramine copper complex. This is a tetracarbonyl nickelate complex. These are some of the examples. Now, double salts when dissolved in water give test for cornlite components. Examples are, as I have earlier, that's cornlite formed by the combination of KCl and MgCl2 exist only in solid state. The solution of these compounds give test for Mg2 plus, K plus, and Cl minus, in which the ions of the constituent compounds. Similarly, more salts gives or positive test for all the components of the salt. Then, with respect to the complex compounds, here when dissolved in water, do not give test for ions of the constituent components. For example, thus the potassium hexacyanoferrate is an addition compound formed by the combination of KCN and ferrous cyanide. Now, the solution of this compound does not give test for Fe2 plus and Cn minus, only it gives test for the K plus with respect to the components. Therefore, Fe2 plus and Cn minus ions club together and results in the formation of a complex ion. This is the here major reason in which here we can face some complexity in the formation of the addition compounds. Therefore, this type of the compounds which are formed by the addition of the simple inorganic salts, in which some of the components loses their identity, these are called as complex salts. Then, what is meant by a coordination compound? In the study of the metal coordination chemistry, the term surrounded by a set of ligands. A ligand is an ion or molecule that can have independent existence. Examples are hexamine cobalt complex, in which cobalt 3 plus is surrounded by 6 ammonia ligands. This hexaqua nickelate complex, in which Ni3 plus is surrounded by water molecules. Like this way, here tetracarbonyl nickelate complex also. Then, how many types of the coordination compounds are formed? Thus, the types of the coordination compounds differs by its charge on the complex ion, then type of the complex compound. Firstly, on the basis of the charge on the complex ion, thus they are divided into two categories. One is cationic complex ion, in which the ionic coordination compound containing complex cation and simple anion, those are called as cationic complex. If the ionic coordination compound contains simple here anion, simple anion, then those are called as anionic complex compound. Cationic complex compound examples are here hexaqua, zinc complex, hexamine, cobalt complex. These are the here cationic complex compound. In case of the anionic complex compound, this this potassium hexacyanoferrate complex, and then a tetraiod mercury complex. That's a potassium complex. The tetraiod mercury complex. These are the examples for the anionic complex compounds. If the two complex ions combine together and forms the complex compound, in which both the ions are present in the complex compound. Say complex cation and complex anion are present. Those are called as cationic anionic complex compounds. Then if there is no charge on the here coordination sphere or coordination entity itself is the neutral compound, then the coordination compound is called as neutral complex compound. Examples are this a pentacarbonyl iron complex, and here that's the benzyl chromium complex. These are the here two examples. If the two central metal atoms linked by the bridging ligands and results in the formation of a complex compound, those are polynuclear complex compounds or bridged complex compounds. The examples are nobedium complex and iron complex. In case of the nobedium complex, this chlorine acts as a bridging ligand, and in case of the iron complex, thus the hydroxyl ion acts as a bridging ligand. Now, here another type of the complex compound on the basis of the ligands which are surrounded around the central metal atom. Those are falls into two categories: homoleptic complexes and heteroleptic complexes. The complex ion in which the metal bounded by only one kind of the ligands, those are called as homoleptic complexes. Examples are hexamine cobalt complex and tetracarbonyl nickelate complex. Now, in case of the heteroleptic complexes, the complex ion in which the metal ion is bounded, metal is bounded to more than one kind of the ligands are known as heteroleptic complexes. Examples are the tetramine dichloro cobalt complex, then here dichloro, that's the diethylene diamine, that's the platinate complex. Next, here if the ring structure is formed by the presence of some organic ligands, those are called as chelated complex. Now, the following are the examples in which the M stands for the metal atom here, which are associated with the corresponding coordination number. Here, now, the important terms and definitions in coordination chemistry. The coordination sphere, the central metal atom or ion, and the ligands that are directly attached to it is enclosed in a square bracket are collectively known as coordination sphere. Example is in case of hexaqua manganese sulfate. In this coordination compound, the central metal ion Mn2 plus and 6 water molecules directly attached to it, enclosed in a square bracket, is called as coordination sphere. That is represented by the following pictorial notation. Now, the NH3 is the ligand, CO is the central metal ion, and here 6 is the number of ammonia ligands which are attached to the cobalt, and therefore cobalt 6 ammonia molecules which are enclosed in a square bracket with a appropriate charge. That's called as a coordination sphere. If the complex compound is a neutral one, then the coordination sphere doesn't carry any charge. Therefore, that itself is the coordination sphere of the complex compound. Then, how to calculate the charge on a complex ion? Thus, a charge carried by a complex ion is the algebraic sum of the charges carried by the central metal ion and ligands coordinated to the central metal ion. That is, charge on complex ion is equal to charge on metal ion plus charge on ligand. In case of the tetra ammonia copper complex, thus copper carries plus 2 charge and ammonia molecules are neutral, that is 0 charge. Therefore, the net charge on the complex is plus 2. Thus, the charge on the complex ion, thus tetramine copper complex ion, thus charge on copper ion plus charge on ammonia ligands, that is 2 plus 0 is equal to 2. Then, here what is meant by a central metal atom or ion? The metal atom or ion which is bounded to a fixed number of ions or molecules which are called as ligands in the coordination sphere, that is called as a here central metal atom or ion. Examples are, in case of hexa-aquo manganese sulfate, Mn2 plus is the central metal ion. In tetracarbonyl nickel complex, nickel 0 is the central metal atom ligand. Then the neutral molecule or ion bounded to a central metal atom or ion in a coordination sphere through coordinate bonds are called as ligands. Examples are Cl minus, Br minus, Cl minus, NO3 minus, OH minus, that's NH3, water, that's the ethylene diamine. These are the examples. Now coordination number. Here coordination number of the central metal atom or ion in a coordination compound is the number of coordination bonds with which the ligands are bounded to a central atom or ion. Example, in complex hexamine, hexa-aquo manganese sulfate, each is a water molecule. Water forms one coordination bond with manganese ion, and as there are 6 such water molecules, coordination number of the Mn2 ion is 6. Now, in complex, thus the tris ethylene diamine cobalt complex, and here tri-oxalato iron complex, coordination number of cobalt and iron ion in the complex is 6 because C2O4 2 minus and ethylene diamine are bidentate ligands. Now oxidation number. This the oxidation number of the central metal atom or ion when all the ligands are removed along with the electron pairs that are shared with the central atom or ion would carry is called the oxidation number. Example, oxidation number of cobalt in hexamine cobalt 3 plus complex is plus 3 and it is written as CO3. Now here this is about some of the basic components of the coordination compounds.